why data mining or machine learning is important. I know that it's intuitively, we would say it's important, right? We don't need to argue much, but let's just conceptually think how actually data mining or machine learning can benefit us. So firstly, for existing solution, let's say you already have existing solution like spam filter, for example, you already have followed the traditional approach, you build up spam filter. So existing solution, that's fine, but would you think that writing another solution using machine learning would be worthy? Actually, the answer is yes. Like when we come to the fluctuating environment or when we have updated data, things are changing, spammers are changing their style. So instead of using traditional and spend a lot of time changing and writing rules, I actually, even if you ask me, just thinking about writing rules would be a hectic thing. And I hated most when I use many if condition inside my application. I hated. So I even try to not to have many levels of if, but I hate it anyway. But I'm just saying you how you may think even applying machine learning might be simpler solution. So even if I have existing solution, I might still interested to move to data mining solution. Now, complex problems, for some problems, even using traditional approach would be impossible. For example, if you have a case where it involves so many factors, when we talk about house price, maybe number of rooms, the area, right? Maybe the location, how far or how near to the train station, to the bus station. Okay, maybe still manageable somehow, right? You can even figure yourself later about the price, maybe the area, KL, compare, etc. But some problems are so complex. So complex. Let's say you have a factory and then the machinery needs some maintenance, right? They might be broken down. They need to change some particular part of the machine, but you need to predict when the lifespan or lifetime for this part is coming to end soon. So how you do that? If you think about it, if I give you a part of the machine, I tell me when is the appropriate time to change. Maybe you will tell me, okay, based on historic data, sometimes the parts need to be changed every 2 months or maybe 1 month or 3 months. Then let's take just the average and every 1 month and a half and change it. Okay, this is one solution, right? You're following, let's say, just based on the data you're checking, sometimes we need to change the part, this gets spoiled or broken after 3 months or after 2 months or after 1 month or maybe even after 1 year. Let's make it worse. And now you come up, okay, well, say, what do you do? 1 month or 1 year? So how to decide? Even if you take, let's say, taking the average, say, well, 6 months, maybe the part will be broken even earlier because 1 month. So what do? You say, okay, let's change it every 20 days. This is even worse because you're putting a lot of cost on the factory. Maybe the lifespan for the part, that part hasn't ended yet. You still can use it for another 10 months. So that means it's a very complex problem. How would you figure out, how would you understand when it is the time to change? So traditional approach, that means just it's out of the question. We put it away. We cannot do it. And we hope for machine learning to perhaps find some solution for that, right? So this is about complex problem. Complex problem, again, traditional approach might come out of the question to apply. Fluctuating environments. Fluctuating environments, let's say like the example of spammers, they change their style, right? So machine learning, again, can be automated. Or maybe the stock price. Stock price is changing so fast, maybe sometimes. Then what do you do to predict? That means you need to stay behind the PC all the time. The prices goes up and down. So fluctuating environment. So again, data mining is good because we can make the process automated, correct? And then we can take the new data and make the changes to the model that we are using. Or getting insights. We have data and then we are interested to get some insights about the data. For example, you gathered about the food consumption for the country, let's say inside Malaysia, for many parts of it, Kampar, KL, and etc. And you like to get some insight. Maybe on average, let's say you may come up with some figures like on average how much every family will consume potato, for example, or tomato, or vegetables, or fish, and etc. But if you like to get insights, for example, certain states, maybe they consume a lot in certain time, and another states consume certain types of food and etc. Or different countries, let's say, you try to find some insights. Just you look to some insights, which country maybe consume a lot in certain time, in certain area, for example, etc. So these machine learning and data mining is still good to give you some insights. For example, you can apply principal component analysis. Probably we come later to it. If you have so many factors, principal component will try to reduce them to smaller number of factors, but at the same time, these factors are still representative for the other factors. So assume I have 100 factor. As I was saying, for example, consumption of vegetables for this state and other states and other states. And then I have, so one factor, consumption of vegetables, consumption of meat, consumption of something else, and etc. And then let's say I have 10 factors, 20 factors. And then I can, if I need to get inside so fast or by myself, let's say, I need to sit down and read these figures and numbers and see how they are changing. But for example, applying principal component analysis actually can reduce the number of factors. It will look to these 20 factors and make them only 2. So now checking 2 factors easier or having the 20 factors. So by only using 2 factors, I can get insights, for example, about these different factors by only using 2 or 3 or 4 instead of having 20. Okay, so even machine learning can still give us some insights.